Rational inequalities. What is rational inequalities? Well, they are inequalities that consist of rational expressions. But before that, what is rational expressions? And more so, what makes an expression a rational expression? Well, we go way back to polynomials. Now, a polynomial is an expression in which its exponents are all integers. Now, the first example is a polynomial because its exponent, which is 2, is an integer, while the second one is not because its exponent is not an integer in a form of 1/2.
Now, here we are solving rational inequalities. Now, there are 7 steps in solving rational inequalities. The first step is to equate the inequality to 0. This is where you subtract the expression on the right-hand side to the left side. Second is to simplify the expression by doing simple subtraction. Third is to equate those expressions from our simplified equation to 0. And then we'll solve for the critical points. Once we have our critical points, we input those critical points in a number line. Then we substitute the critical points to determine whether they are solutions or not. Now, where are we going to substitute those critical points? Well, we're going to substitute them on our simplified expression back in step number 2. And lastly, we'll substitute the remaining values on a number line to determine whether they are also solutions or not. But before that, we'll first tackle what are critical points. Well, critical points are values directly derived from an inequality that would be used to determine solution sets since they provide values to use in solving. Here we are given an example, a simple rational inequality. 4 over x plus 1 is greater than 2. Now, first step is to equate it to 0, so we subtract 2 on both sides and we have our simplified expression. 4 over x plus 1 minus 2 is greater than 0. Second is to simplify the expression by doing some simple subtraction, getting the LCDs, and there you have it. Simplify it even further and we have our final simplified expression at the form of negative 2x plus 2 over x plus 1 is greater than 0. Now third, we equate the expressions to 0. As you can see, we have two expressions here, negative 2x plus 2 and x plus 1. So what we do is that we equate both expressions to 0. And then fourth, we solve for our zeros or critical points. And we have negative 2x plus 2 equals 0. If we subtract 2 on both sides, we have negative 2x equals negative 2. We divide negative 2 on both sides, and we have x equals positive 1. And we do it on the other equation as well. We subtract 1 on both sides, and we have our second critical points, x equals negative 1. Fifth is to input our critical points in a number line. So here we have it, negative 1 and positive 1. Now, you may ask, why is there 0? Well, the 0 is there in order to determine whether the values between our critical points are solutions or not. 0 is just there in order to not get lost during our process. Now, sixth is to determine whether our critical points are solutions or not via substitution, and again, we substitute them on our simplified expression back in step number 2. So we have x equals positive 1 and do some substitution and addition and subtraction and division. We get that it is not a solution because it is 0 greater than 0, which is false, so therefore it is not a solution. So we put an empty dot above our critical points, x equals positive 1. We do it on our second critical point, x equals negative 1. We do the process, and as you can see, it is undefined because, as the rule suggests, any number you divide by 0 is always undefined. Therefore, it is not a solution, and you put an empty dot above our critical point, x equals negative 1. Now, what if our critical points are solution? Well, that empty dot would be a solid dot, not an empty one. Now, seventh is to determine whether the remaining values in the number line are solutions or not. So we'll try first the succeeding numbers after x equals positive 1. Let's try x equals positive 2, nearest 1, so it's gonna be easier. And as you can see, it is not true. The inequality is not true, therefore it is not a solution, and you don't have to do anything in our number line. But what if it is true? Well, we put an arrow, which means that it extends towards infinity. Now here we have x equals 0. Between our critical points, x equals positive 1 and negative 1. And as you can see, it is greater than 0. Therefore, it is a solution. And what you're going to do in our number line is to draw a line bridging our critical points. And lastly, we have the values beyond our last critical point, which is x equals negative 1. So we'll try negative 2. And as you can see, it is also not a solution. Therefore, you do not do anything with our number line. So we have our final answer in interval notation form, negative 1, comma, positive 1, both enclosed in parentheses. As you can see in our number line, it's only the values between negative 1 and positive 1. A little detail to be reminded, brackets are for critical points that are actually a solution. So as you can see, there were no brackets in our final answer because our critical points are not solutions. Parentheses are for critical points that are not a solution, just like what we have a while back, or whenever a solution extends towards positive or negative infinity. Here is another example of a rational inequality, but this time it's a bit of a complex one. So this is the first step to equate the expression to 0. Second step is to simplify the expression. Third step is to equate our expressions to 0 in order to find the critical points. Fourth is to solve for our critical points. This is our final critical points, negative 2, negative 1, and negative 4. Next is to input the critical points in a number line. And then 6 is to solve the critical points to determine if they're solutions or not. Again, a solution is a solid dot. Seventh, determine whether the remaining numbers are solutions or not. And the final answer would be in interval notation form, negative infinity, comma, negative 4, both enclosed in parentheses, union with negative 2 enclosed in parentheses, comma, negative 1 enclosed in bracket. Again, because it is a solution, negative 1, while negative 2, negative 4, and negative infinity, there are parentheses because to negative infinity, or they are not solutions. And that's it about rational inequalities, and next video would be all about rational functions. Thank you for watching.